Hi, everybody. Thanks for joining. We'll get started in a minute or so. Just let people join. All right, let's get started. Hi, everyone, and welcome to today's Better Buildings webinar, dedicated to bringing you the latest actionable insights from leading industry experts. Better Buildings webinars are a chance to explore the topics, technologies, and trends that affect your organization, as well as efforts to accelerate energy efficiency strategies and reduce costs. Next slide, please. Today's webinar is called Beyond Curb Appeal, Exterior Upgrades That Drive Efficiency and Savings. Before we dive in, there are a few housekeeping points I'd like to cover. Please note today's webinar will be recorded and archived on the Better Building Solutions Center. We will follow up when today's recording and slides are made available. Next, attendees are in listen-only mode, meaning your microphones are muted. If you experience any audio or visual issues throughout the webinar, please send a message in the Q&A box located on the bottom of your Zoom panel, and our tech support team will be in touch. Next slide, please. My name is Claire, and I'll be your moderator today. I work at ICF supporting the HUD and DOE Better Buildings Multifamily Initiative with developing programming like this webinar and our annual summit. And I also support multifamily partners who are working to achieve a 50% emissions reduction or a 20% energy efficiency goal as an account manager with these partners. Next slide, please. In today's webinar, we'll talk about how strategic exterior upgrades in multifamily buildings can do more than enhance curb appeal. They can drive real energy savings. This session will explore innovative solutions like high-performance windows and exterior insulation panels and show how these technologies can boost building efficiency and long-term value. Next slide. Today we'll be using an interactive platform for Q&A and polling. Please go to slido.com on your mobile device or by opening a new window in your internet browser and use the event code DOE. If you would like to ask our panelists questions, please submit them anytime throughout the presentation. We'll be answering your questions near the end of the webinar. You can select the thumbs up icon for questions that you like, which will result in the most popular questions moving to the top of the queue. Next slide. So to kick us off, I'd like to start with a polling question for you all. Please join us over at Slido to respond to the following question. If you have any issues, please message our tech support team by using the Zoom Q&A function. And remember, it's slido.com and event code is #DOE. So the question is, which best describes your organization's experience with exterior insulation panel retrofits? Looks like we have a lot of folks not familiar, but excited to learn, which is great. You come to the right spot. All right. Looks like people are just excited to learn a little bit today. All right, I think we'll get started. So we have a great lineup of presenters today. Our first speaker is Eva Rosenblum, manager in the buildings practice at Rocky Mountain Institute, or RMI. And our second speaker is Will Monson, senior project manager at Homeowners Rehab, Inc., or HRI. Thank you both for joining us today. Next slide. So like I said, our first speaker is Eva Rosenblum. As a manager in the buildings practice at RMI, Eva oversees strategic, affordable multifamily housing and commercial building energy efficiency retrofit work streams in Massachusetts, working with technical designers, building owners, manufacturers, and local and state agencies She facilitates the establishment of more systematic processes and programs that can expedite resource distribution and drive durable market shifts in building retrofits. As a registered architect, Eva has over 25 years of experience in design, project management, systems thinking, and advancing industry practices with change management leadership. And with that, I'll hand it off to Eva.
Great. Thanks, Claire. I just realized that dated me a little bit too much, but well, that's okay. Hello, everyone, and good morning. And I'm super excited to be here to kind of dive into a storytelling of what we've been up to for the last couple of years and what all of that description meant. So at RMI, we lean heavily into extensive market engagement, working at multiple levels from research and analysis to this programmatic and policy, with some hands-on work supporting specific leading edge construction projects, all of this with a consistent eye for scale. So today I'm going to present to you a bit of a summary, a status and progress of the building retrofit projects that we've been supporting and involved with over the last 3 or 4 years and what we've learned in the process. I will note that most of these projects are in Massachusetts and one is in California. That does not mean that these are exclusive to these areas. I would consider Massachusetts as an aging building stock in cold climates, and California as housing is a low rise in milder climates. So same rules apply. So I hope this will be informative. Do I have the next slide, please? So through our experience kind of on the ground, a couple of things came to surface as being pretty obvious. Obviously, everyone's aware of barriers, and I'm sure none of these really strike you as something you haven't heard already. But what we did pick out were some enablers within the market and in industries that did make things just a little bit easier. And those were extreme tight partnerships across stakeholder groups. The building industry is a pretty big ecosystem with many stakeholders along the different process, and everyone touches a building in some point. And so trying to overly engage is very helpful in developing a new industry practice or change. Lighthouse projects, demonstration projects are really key to demonstrate what's possible and really inspire others to follow. And then knowledge sharing and influence with data. This is kind of twofold. Knowledge sharing, obviously, keeping the lessons that any one team has learned, passing it along so that the next team doesn't have to go through the same process. And then also taking data, doing more of a measurement and verification afterwards to better inform new programs and maybe emerging programs coming down the line, what projects really need. Could I have the next slide, please? So here's a snapshot of some projects in the works or recently completed, just to give you a sense of the different building typologies that we've been working with. The most important thing that we'd like to communicate here is that certain research and market development wouldn't happen without these initial research and collaborative projects. They have been historically able to expand the industry by taking just a little bit more, and I'll say perceived risk on nascent technologies or construction approaches, which then can turn and pave the way for more R&D and smooth the path for additional products to come to the commercial market. So today we are highlighting these lessons from these 4, 2 mid-rise and 2 low-rise. Next slide, please. Our first one that we're going to talk about is Fairweather Apartments in Salem, Massachusetts. This is an affordable housing, about 160 units or so. This is undergoing an extensive exterior overclad using prefabricated panelized panels. We have panelized design and an exterior mechanical system. So these panels are manufactured locally, and then they are installed with a good 6 or 8 inches off the face of the existing facade. And within that space, they are able to install a new central mechanical system, which would ease the burdens for long-term maintenance, but most importantly, the disruption to tenants is significantly reduced. From this project, we're estimating a tenant relocation in and around a day to tie in the windows and do some tweaks to the mechanical systems. This project is realizing significant reductions, 85%, and is looking for a lot of different indoor air quality benefits and utility burden reductions with that. Next slide. So I'll promise you, we'll tell you what we did, and then now what we know, kind of give you the inside to starting where we left off. The big things for Fairweather is that an integrated design process from day one is really helpful and almost completely necessary with these types of explorations and pushing out of the box of new approaches that could help construction innovate. If it was not for the extensive coordination among these teams, there would have been significant delays and increases into cost. And one great example is when the fire rating code officials first saw this, they interpreted that gap as a shaft. And that would be bad because everything inside the shaft would have had to been significantly rated, and which would have caused a lot of headaches. So through additional engineering judgments, the team was able to work with that stakeholder group and get it so there was an extension of the exterior envelope. So the point is here, early communication, early assessment of structural integrity, and obviously consider the site especially with prefabrication, what can you access and what can you not? Next slide, please. Eva White is a very similar type of building and a similar type of approach. This one is located in Boston, which is facing building energy reduction ordinances. So this wasn't necessarily about the extension of the building, but a primary driver, not the primary driver, was to reduce emissions on a regulatory basis. Eva White uses the same mentality of running some new mechanicals down the face of the building in between the old and the new. Although this design was created a new curtain wall assembly and then used Kingspan insulated panels hung on that scenario. Next slide. So what did we learn from this one? A lot of thermal analysis, like the preliminary, I would say across the board with any existing building, as much of the preliminary analysis you can do will help you in the long run. This project definitely suffered a little bit from the nascency of the market, slowly building momentum. The project team spent about 3 years vetting and engaging with details of 4 different overclad systems. So they were not yet trying to get things that were commercially viable or backed sufficiently, and that took quite a bit of time. So we are now at that point where things are coming to market, but paying attention to that initially and planning for it is beneficial. Next slide. So Hano Homes. Hano Homes just completed. It's also in Boston. It's a low-rise 20-unit mixture of like 5 or 10 duplexes. There were many obviously in the facade constraints that dictated that this was not an appropriate building for a panelized construction and more of a site-built approach. So, but in doing that, the project team really wanted to look at how to minimize those tenants. So we were able to figure out a scenario where they had a swing space, and so the tenants were only relocated for 2 weeks, but again, a high coordination there. This is, there's 5 inches of wood fiber insulation on top of with fur and strips and a new siding with this. This is realizing also significant energy savings in the 70% range. Next slide, please. So our lessons here are what I had mentioned before, exploratory demo. The more that investment in the initial really kind of over and above what you would think would be necessary will really pay off in the end. Looking back, I think talking with the project design team, they would have gone a couple different routes or prioritized some other aspects if they had known what they were going to deal with an old building. So that's an easy takeaway from this building. Next slide. So our final example is, I'll share today, is the low-rise multifamily in California. So being a milder climate, this project didn't necessarily have to conform to a larger thermal capacity with the panels and the overclad system. This panel is a combination of a dry-vit thermalite lightweight and a revitalized panel, one being a light structure with no frame, and the other one having an interior frame depending on the facade and the installation method. Next slide. And the lessons here, there's kind of three big takeaways that came out of this project. This was one of 4 buildings in California that we investigated different options. And so in mild climates, the panelization didn't necessarily pencil out unless other base building issues were being addressed, like severe facade failure or seismic issues. That in the other properties, a lighter touch solution with some added insulation and very extensive attic sealing, air sealing in the attic, proved to have more promising results and economically more justifiable. The other thing that we want to mention here is definitely that with any of these new technologies, as far as scanning or installation methods, again, it's really important to get that early buy-in from everyone on the team to be comfortable with what is expected and what to do. This project, some of the construction team didn't trust the initial scanning, so there was a lot of double efforts in existing measurements, and that was really unnecessary. Next slide, please. So I'm sure, again, doesn't shock anyone that how complicated these projects seem to be, and there's still quite a bit of work to do to scale them. Through our just observations and our experiences, we realize that cultivating this ecosystem is really central to a sustained market on literally construction industry itself. Couple thinking changes that would be helpful to have, and that's thinking about the building as a whole building and not necessarily a component, mixture of components. Standardizing scope where possible, using baseline and case studies to start halfway down the line instead of from ground zero, and then looking beyond these incremental costs from a standard retrofit to an energy efficiency retrofit, and see what those benefits could really be or have hidden value for the owner. And then our contrasting the strategic actions we're really focusing on is this building market capacity, creating the favorable landscape with policies and connection to funding, and making it a whole heck of a lot easier. So support in any of these categories is beneficial, is very helpful, but you need support in all of these categories. And next slide, please. And so when I talk about market capacity, this is really what we're trying to convey, is that the current trends are declining. We have an aging workforce that is facing retirement within probably in the next 10, 15 years, and the downward trajectory is already happening. So having just even a base maintenance demand, there's going to need some work to do that. The reality is we really can't afford to slow down with housing crisis and other issues. We need to keep going and recognize that we need to fill in that big blue area. So investment, focusing on innovation and investing innovation, looking to have partners that really explore what are the best ways we could be approaching, best, fastest, and most affordable ways that we could be approaching these types of projects to meet the performance goals. So investments in manufacturing products coming to commercial market contractors. Gap funding still initially is needed just to get this momentum going. And as project delivery teams become more efficient and production scales up, the costs and market capacity will grow and the costs will start to level out. So then we'll start to see these scales increase. And next slide, please. And that is the conclusion of my presentation. Happy to obviously answer any questions. I know that was a lot of information, but I hope this was inspiring to give a project a shot.
Great. Thank you so much, Eva. That was a great presentation. And a quick reminder to our audience, please send in your questions that you might have to slido.com, event code DOE, and we'll be addressing your questions at the end of the session. Now we'll hear from Will Monson. Will is a senior project manager at HRI, which is also a Better Climate Challenge multifamily partner. Will joined HRI as a project manager in July of 2017. And while at HRI, he has helped with several projects in Cambridge, Massachusetts, including the rehabilitation and financing of Auburn Park, the financing of Concord Highlands, and the financing and rehabilitation of the Rivermark, which we'll hear about more today. Will received his master in city planning degree from MIT, focusing on housing, community, and economic development. Over to you, Will.
Thank you. So I will be talking about Rivermark, which is the picture, the building pictured here, which I worked on when I came to HRI, and we through construction, which finished up only a couple years ago. So it was a long running project. And I'm not an architect or a designer by training. I work in the numbers side. And I think given the large audience here, I'm trying to keep the 10,000 view point. So try to say kind of walk through our experience with this building and especially getting ready for the construction and kind of the questions about why to overclad or why to do the work that we did. So I'll try to kind of maintain this very broad viewpoint, not get too in the weeds, and happy to answer any questions afterwards too. Next slide, please. Just a quick overview of who we are. HRI, we're based in Cambridge, Massachusetts. We have over 1,600 units of rental housing, of which 1,500 are in Cambridge. We have some units in neighboring communities in Somerville and Newton and Watertown, if you know the Boston area, which translates to nearly 5,000 residents served in 2,000, nearly 3,000 bedrooms. So it's a fairly large, diverse group of residents, and we have all types of housing to serve that diverse group. Next slide, please. We were founded a little over 50 years ago in Cambridge, mostly focused on the home improvement program, so helping homeowners fix up their homes. And then over time, especially as Cambridge has changed and become more expensive, and affordability crisis has gotten larger, we focus more on affordable rental housing. So the latter half of that 50 years, we've gotten into rental housing and affordable rental housing and participating in the low-income housing tax credits and developing our own projects in addition to acquiring existing projects. So I work on the development side of things with those rental projects. Next, please. So today we'll talk about one of these buildings. It's our largest building, Rivermark, formerly known as its address 808-812 Memorial Drive here in Cambridge. Just a quick overview of the building. It was built in 1974 by another developer using HUD's Section 236 program. We acquired it in 1997 from the for-profit owner. We're a nonprofit. We purchased it through the LIPFRA program, which I always forget the acronyms: Low-Income Housing Preservation of Rental Housing and Resident Home Ownership Act, which was essentially a program in the 90s to help purchase old HUD programs from the 60s and 70s that were at risk of expiring use and flipping to market, losing its affordability. So that's how HRI acquired it. We did a modest rehab at the time, but most of our capital stack went into the purchase of the building, so we were only able to do some new windows, a little bit of waterproofing, a new roof, kind of a very limited scope. Um, we were planning to, it was syndicated as part of low-income housing, using low-income housing tax credits, which is a 15-year period. At the end of that period, in 2012, we were planning to do a new resyndication. It got delayed for a whole other story. We had a year 15 issue with our investor, had to be resolved in the court system, went to Supreme Judicial Court. That happened in 2018, but we're delayed in our resyndication to do the much larger scope that we now did here. So in the meantime, in 2015, we issued an RFP for an in-depth review. End up choosing Brunner Architects to lead that study, and then ultimately do the renovation scope. So we're looking at doing a lot of investigative testing, looking at the envelope, the structure, the MEP systems, all sorts of stuff. And we selected them in 2016. We closed in 2020. Again, it was delayed by the lawsuit, and essentially we also just needed that much time to really wrap our heads around this complicated deal. Next slide, please. Here is just an old sketch from the original architect in 1974. You can see the building there. It's pretty cool. The hand-drawn sketch of the building back before CAD. Next slide, please. And here's some more modern pictures before the renovation. So you can see its location here in Cambridge on the Charles River. For those who are familiar with Boston, that bridge there is how you enter Cambridge off the Mass Pike. So this is really kind of a landmark going into Cambridge. You pass it. It's pretty easy to spot the 19-story building right on the river as you drive into Cambridge. I believe the only affordable housing on the Charles River. I might be wrong about that, but certainly the largest. So you can see the what it used to look like was the kind of gray, classic 60s, 70s brutalist high-rise tower look. Next slide, please. So when we acquired the building in 1997, it had ongoing water leaks. It was just kind of inherent to the design of the original construction. The way that the precast concrete panels came together was just failing caulk joints, and I believe there's 300 units in the building, and I believe over 200 had ongoing leak issues at the time. So in our 20 plus years of ownership, it was kind of like playing whack-a-mole. We'd get a complaint about a water leak, we'd go chase it down, re-caulk, reseal, and then inevitably it'd fail over time. So that was the primary goal of this, was improving the envelope performance, was eliminating those water leaks and also just improving the thermal and air sealing performance. So having cold areas, having drafts, improving the experience for the tenants. I think that's like a helpful thing to pause at. I mean, in this larger question of why should we overclad? I think in my mind, there's a kind of three main buckets, and one of them is the curb appeal, the aesthetics of the building, which is great. But as this kind of discussion's about, they're saying beyond curb appeal, you want to look at performance of the building. Certainly getting higher energy efficiency is great too, but for our particular case, it was really about the performance and addressing these longstanding issues. And this was kind of the only way to do that was this overclad superstructure, essentially a new construction around the existing building, just given everything that was the particulars of this building, which I'll get into in a second. So that's first and foremost the primary building goal. In addition, we just had a lot of other capital work that we did as part of this larger scope. So we replaced the 6 elevators. There's 2 in each residential building, 2 residential buildings, and then 1 in the commercial space and 1 in the garage. We also added accessible units, so type 2A, fully accessible units. So 15 in a 300 unit building, so 5% of the units made fully accessible. Reduced water usage, which is our largest utility cost. So just in the course of renovating bathrooms and kitchens, putting in low flow fixtures, it helped reduce a lot of costs as well. And as I already mentioned, it wasn't the primary goal, but a very important ancillary goal was improving the energy efficiency of the building with this exterior insulation and air sealing. Also, community goals, this wasn't occupied rehab. That's, we have 300 households living in the property, and most of them are affordable. So there's not many places you could relocate someone for a 31-month construction period. So you had to figure out how to do it with people living there. So that was part of the goal, is figuring out how to safely do that. We also wanted to add better wayfinding and placemaking. We focused a lot in the interior courtyard renovation and making that a more pleasant place for residents to hang out. And it also improving the interior community rooms, which hadn't been upgraded since we did the 1997 renovation. Next slide, please. Just a little more deal basics. And I think this is a very unique project, so I doubt anyone has a project even close to like it, but it's a 300-unit high-rise building. There's 212 deed restricted affordable units, and there's 88 market rate units. So it's a mixed income building. There's two buildings. There's building A, which is 19 stories, the taller building, and then building B is slightly lower, 11 stories. If that wasn't confusing enough, it's a mixed use building with 38,000 square feet of commercial, mostly along the first through third floors in the building A. And so as a result, we actually had kind of two different scopes. We had a commercial scope that was financed by East Cambridge Savings Bank for $11.5 million. And then we worked with Mass Housing, which is the housing, the quasi-public housing finance group up here in Massachusetts. They do a lot of affordable deals and deals with at least 20% affordable units in it. So we use tax-exempt bond financing, so $61.5 million perm loan, and this is in addition to construction, both taxable and tax-exempt bridge financing. And then we used 4% LIHTC, low-income housing tax credits, getting $37 million of LIHTC equity to finance the residential portion. So again, the unique feature of this, it was a part of the HUD 236 program, which allows you, when you prepay that 236 mortgage, HUD sends us enhanced vouchers for all the tenants who didn't have weren't in a project-based unit. So that's having tenant operating subsidy for paying rent, or tenants only pay 30% of their income, and then you have the subsidy that covers the rest. So we worked, once the residents received those enhanced vouchers, we worked with the Cambridge Housing Authority to project base them, to take that subsidy and tie it to the unit, and that allowed us to finance this large permanent loan, because now we had the subsidy tied that they could underwrite to. So that was a large process, convincing hundreds of residents to essentially say, take your mobility and allow it to stay with the project. We know you want to stay here long term, and we need to tie this subsidy to finance the renovations that'll improve your living space. So the involved a great deal of trust and time working with residents to let them have them understand that, but allowed us to develop the capital stack that we needed in order to finance the renovation. We also had to balance the deals of a low-income housing tax credit deal within the project-based voucher structure and within the LIPFRA framework. So that's the program in the 90s that we acquired the project from, has its own kind of framework to work within, and it's always a bit of a square peg round hole situation. So I had to figure that out working with HUD. We also utilized the average income election, which was something new that was created in 2018, which allowed for slightly higher average area median incomes that qualify for as a LIHTC unit, up to 80% AMI, as long as they average out to 60. So that worked well for a deal like this, where you have people who've been living in this building since before LIHTC even existed in 1986. So you had incomes kind of all over the place, and this allowed us to grab some people who were slightly above the traditional 60% level and allow them to get included in the LIHTC deal. And then we also created a condo structure to carve the commercial space out of aggregate basis for the 50% test. So that's a lot of in the weeds about finance. I just put that out there kind of to frame how unique and complicated this is. I'm happy to answer any other question about finance. That's my side of things. I can't answer as much stuff about the cladding and design details, but I can do my best. And if there's any particular questions about that, I can follow up with our director of construction. So it's a lot of information, but that's kind of the overall deal structure. Next slide, please. I think this is kind of the most important slide, and this is from a presentation that our director of construction did with our architect, Bruner Kott, and it kind of goes over the different things we were thinking about as from 2015 up until we close in 2020. So this kind of half-decade period while we're waiting for the lawsuit to resolve, but also just kind of wrapping our heads around this very complicated building. It was like, how do we approach it? What are the key questions to ask yourself? And I think the most important ones of these is probably the one on the far left side about the building skin and the structural components, because that was the most complicated and is kind of the crux, the largest part of the rehab was this overcladding superstructure over the existing building massing. So one of the main things about this, I mean, I think our architects said this many times in our meetings, was they just couldn't understand, what the original architect in the 70s was thinking with the design. It's a very unique design to say the least. It's not your typical rectangular massing. It's got acute and obtuse angles. You've got stepped uh, building floor heights. So thinking about how to attach cladding to that involved thinking about, hundreds of different unique details about where the cladding would come together, and you have to model it and make sure the dew points are okay, and thinking about the attachment mechanisms. So it took a long time to think about this particular building. Maybe if you have other buildings that are kind of more typical rectangles, it's not as complicated, but it took a long time to think about that. We also wanted to think about the existing building kind of unique features. So this one has uh, concrete panels as floors, and then it has CMU blocks that span between the floors. And we were thinking about originally removing those CMU blocks and maybe building in those places. So that would be a reclad rather than overclad, but it was built in the 70s, and behind that CMU block is uh, an asbestos tar paper. And so talking with our GC, we're saying, well, it's theoretically possible, but it'd be extremely expensive to try to encapsulate the CMU, once you remove the CMU block, on the 19th story hanging off this tall building, right on the river with the wind coming off the Charles River. So that wasn't really an option. So we kind of ruled that out. We were also talking about, similar to what Eva was talking about, what is the exact overcladding approach we take. And I think the terms I remember, we talked about a sandwich approach versus the burrito approach. So the sandwich approach being put up the air vapor barrier, the new insulation, and then a rain screen, kind of assembling it on site, versus the burrito approach is using the Kingspan panel that Eva was talking about, where it's built in a factory. It's all in one packaging. You just place it on the building. And so we end up going with the latter because, again, hanging off a building in winter, 19 stories up, you'd be worried about the quality, and will the building perform if you're building it in the field versus building in a factory and just assembling. And also would help the overall timeline, which was already a long timeline, and we wanted to minimize as much as disruption as possible. So I think, thinking about all those things, hazardous materials, the overall integrity of the building, how it's designed, certainly appearance as well. Those are kind of the most important questions to be asking yourself. Just quickly sucking the second one, we replaced the existing boiler system and we replaced the fan coil units in units, but we didn't mess with the overall distribution system. It's still hydronic, still gas fired, but I think that's something you'd want to ask yourself if you are changing the building mechanical systems and distribution systems, how it would pair with your new skin overcladding. Would you want to run chase and line sets through the outside as long as you have the building opened up? So just thinking about that. So the other thinking about this building, again, it was an occupied rehab. So we had to do all this work with tenants in place during the height of COVID, which was not easy to say the least. And so we use the the fact there was two buildings to our advantage. So we had one where we went over cladding on the outside, and the other side simultaneously did rehab on the interior and worked our way down. And we used vacancies in the market rate units to temporarily relocate households for a whole floor, do all the work interior, and then move them back. So that was an advantage we had with the market rate units and the two buildings. But I think thinking seriously, if you're doing an occupied rehab, seriously thinking about how this will all work is almost as challenging, if not just as challenging, as thinking about the architectural and engineering components. Next slide, please. So just this is from the 2016 report. You can kind of see the small details of what we're dealing with. All these small cracks where water was getting in, seeping into apartments, creating issues. So all these hundreds of small details around the whole building that we had to have our team kind of think about. Next slide, please. And then here are the different options we were thinking. We ended up going with the Kingspan insulated metal panel, option B, but we considered doing that built up approach with the rain screen, which was more expensive and probably would not have as of good quality control. And then the cheaper option being EFIS, but just wouldn't hold up as well over time. So I think just assessing all our options, looking at both cost and performance and how it would impact the overall timeline is just all important questions to ask. Next slide, please. Here's in process. You can see the new cladding going up over, and then the old cladding on the building A, the taller building in the back. So kind of in the midst of it. Next slide, please. And here we're just doing some before and after. So here's the old community spaces that, again, we hadn't touched since our 1997 acquisition and rehab. So looking a little tired. Next slide, please. And then after the renovation, focus on improving those spaces, making it more tenant friendly, allowing for better programming, put a better mail room in to accommodate packages, just generally address our tenants' needs. Next slide, please. Here's a typical in units, so you can see the water damage in the top left there. Tired old bathrooms that we didn't do in 1997, so that's original bathrooms from the 70s. Kitchens from the 90s and the old fan coil unit there on the balcony. Next slide, please. And then afterward, it's freshened up a lot. New flooring, new improved living spaces. Everyone got new bathrooms. Most people got new kitchens. It was all modernized. And then, yeah, the balcony, the new railings, and improved space. Next slide. This is just an example of, the kind of details that we went through with Brunner Codd, our architect, and NEI, our general consultant. So going over the different types of facades on the building. You've got your precast bookends on the end. You've got your CMU walls. You've got the commercial facade, and all of those just have different typologies that you have to think about how the connections go. So, literally measuring out by square footage what those spaces are and just planning out where everything's going to go. Very, very complicated. Takes a lot of time to kind of think through that well. So we had the luxury of time here, but yeah, it certainly took that whole time. Next slide, please. And then, it wasn't like I said before, the primary goal was about tenant comfort and livability, but an ancillary important goal was improving overall site performance. And I got this from our folks at BCC. We're part of the BCC challenge, and we track building EUIs, and this is our property EUI for Rivermark over time. So that the construction again was from 2020, finishing up the very end of 2022, early 2023, and you can see the drop in overall EUI from both the replacement of the boiler with a higher efficiency boiler, but also with the overcladding, additional insulation, and air sealing across both buildings. Next slide, please. And then here's another before and after again from the view across the Charles River. the same view, you can see the aesthetic appeal, the curb appeal. In addition, it was another ancillary benefit, but for all the reasons I listed above, it wasn't the primary driver. It was, but it was a nice additional benefit. And I think next slide. Another thing I think is, again, from the 10,000 viewpoint, 10,000 feet high viewpoint. Some things I always think it's helpful to think about the trade-offs and what things we didn't pursue because we just didn't have the capacity, or we were asking too much of the tenants. So we talked with our energy consultant, and we have all these balconies that come off of the building, again making it very complicated from a modeling and from a design standpoint to overclad. And it would have been easier and probably more energy efficient to close off those balconies and not have the returns come into the balcony with the overcladding, and thinking about all those new corners that were created for our GC to figure out and dew points for our architect to model. But we were already asking a lot of the tenants. These are tenants some of them have lived in the building since it was built in the mid 70s. So to take away their balcony and their the ability to use that was asking a little bit too much. So we decided not to enclose the balconies. But that was a trade-off we decided to make. So I think it's always helpful to think about those trade-offs when you're thinking about overcladding or what kind of scope you want to include or not include in your building. We also just decided to upgrade to the higher efficiency HVAC. Again, I mean, it was already a very expensive project, and we already took half a decade to kind of think about just the overcladding component. So it was a little bit much to loop that into this one. But I think in a future upgrade of the building, we would looking for higher efficiency and probably electrifying the systems. But for now, we just used a higher efficiency condensing boiler, and we replaced our cogen, which is cogeneration using gas to create electricity and hot water for our domestic hot water system. So we did that for now. In a future upgrade, we'd probably look at that and pursue that more specifically. Also, just we have this commercial space, we have a parking garage, and we talked briefly about, well, what if we could create more units at the time? But again, taking away a parking garage structure where the tenants park, that'd be asking a lot. It'd be biting off a little bit more than we could chew, given how big the project was already. In addition, we kind of wanted to keep the status quo of the office space at 38,000 square feet. But yeah, and maybe in hindsight with the new where the office markets are now, it's a little bit harder to rent up office, even in places like Cambridge. So maybe in a future renovation, we might look at conversion of that space, try and create more affordable units. But we did not do that here. Next slide, please. I think that is it. So there's one more view, a rendering from a slightly different angle. So happy to answer any other questions, either broad 10,000 viewpoint or more specific as best I can. Thank you.
All right. Thanks so much, Will. And yeah, thank you, Will and Eva, for such great presentations. Yeah, I think now we're going to move on to our Q&A. If you haven't already, please join us on Slido with the event code DOE. And so it looks like quite a few of you have already asked some questions. Let's see. I think some of them are kind of related to similar themes, so I'm going to try my best to kind of combine some. I noticed we've had a few questions come in on project economics, including monetizing the non-energy benefits. Can either of you guys provide a little bit more information on kind of the cost of installation and the long-term energy and cost savings for the building?
I think that kind of gets to what I was saying. I mean, certainly that's a benefit, but I don't think on its own it would necessarily, the payback would be quite a long payback for just the cladding alone. But it was really about the tenant comfort, and I think that was the primary driver here, more than any savings from just from reduced gas and electricity usage.
I'm just going to add, so you can see that, the owner is driven by a whole different factors. I answered in one about monetizing non-energy benefits. There's a lot more aspects that need to be included in a life cycle cost assessment analysis when you're looking at a project. We like to lump these into avoided costs, like what would you have done in the building? Like what would have been your maintenance and your repair costs if you don't change it out, and then what would be your avoided risks. Risk could be regulatory fines, any fluctuating fuel prices, or even there is a point with most buildings they could trigger a code upgrade anyway, with a certain amount of renovation. So there, you really have to kind of put everything on the table to be apples to apples. And so those are the real dollars. The value add, these non-energy benefits, like what Will was saying, there's added indoor air quality and thermal comfort for the residents. Not disrupting the residents during a construction time. It has both a financial value and a kind of benefit value. We're doing research into increasing property values and lowering insurance premiums or health effects. One property, the Hano property, when things are mastered metered, it's highly beneficial for the owner. The owner, well, even though that extensive overclad will not necessarily kind of pencil out, because of the reduction in utility prices, the owner now has more operating reserves in their yearly plan. So it's not so black and white. You really have to look at all of these other things that could come into play.
Great, thank you. Let's see. So a popular question I'm seeing, it says, for the panelized construction solution with bump out, did you have to go through any specific zoning regulations, aesthetic restrictions, easements, etc., to go over public space?
We actually did. So the overcladding package, that Kingspan panel, would ultimately increase the it's about 12 inches, like a foot outboard from the building. And so technically you're putting on the existing building, so the whole building is going to expand by a foot outwards, so that technically increases the gross floor area. It's also obviously a non-conforming building, a 19-story high-rise in Cambridge. So we'd also technically be going into our setbacks. So we did have to go in front of the BZA, the zoning board here in Cambridge, and ask for variance to allow us to do this. I mean, the zoning in Cambridge specifically, they do have language in the zoning code that allows for additional insulation on the outside of buildings, but unfortunately it's only for I think 4 to 7 inches, because I think what they're imagining was a single family house adding insulation on the single family house, which is about that size. They didn't allow for a 19-story high-rise building adding insulation, but it wasn't a problem. I mean, they gave us the variance. It was fine. It was just an exercise we had to go through. But yes, technically we were increasing our gross floor area of the building and encroaching into the setback, so we had to ask for relief on that. So something maybe to be wary of, where if you're thinking about doing an overcladding as well, just to check that box.
Just
under due
again,
diligence.
the early assessment and early coordination is really key to understand.
Thank you. I'm seeing a question that has come in about climate zones. Specifically, do these systems work in warmer climates? What approaches work best for dry climates like Southwest or humid climates like the Southeast?
Mhm. So yes, every climate is going to have a different approach. You in the Northeast, where it's a heating dominating climate, where in the South and the drier it's more of a cooling. So there is a little bit of a building science aspect to consider. So I would definitely refer to both like the energy codes and then the thermal capacity and the air tightness for each individual climate zone. But also, there was a couple questions about moisture and mold, and the most important thing with when you're tightening up any structure is not you're stopping the natural ventilation, but you need to control it with a mechanical ventilation. So that always has to be a part of the equation, and that constant ventilation will reduce and limit moisture from having that mold growth.
Yeah, I don't have anything else to add.
I guess in that vein, kind of on the note about water, water leakage and moisture, um, for a building with water leakage around windows and gaps in buildings, where would you begin to analyze opportunities for building facade upgrades? Is there a certain study that should be completed?
Yes. Yes. So, again, early engagement, even if you're looking out to a refinancing cycle or a couple years, the more you start talking, the better. The best mechanically and kind of conditioned, you can start with a capital needs assessment, like what is your equipment, how is your equipment performing, and what is that? And then there's also an energy audit, and there are varying levels of energy audits. And Will has gone through this many times, so I'll let him describe the different things. But having that investment in that initial feasibility stage definitely gives the owner more flexibility and more options and just more awareness of how their building operates and what would be the best outcome for.
Yeah, and for this building, we had worked with Bruno Cott to do an existing conditions study, which I don't know if, I mean, I don't think that's it's a good generic term maybe, but really they just looked at the specifics of the building, like getting all those detailed shots of kind of typical conditions at windows, at caulk joints, where the panels come together, and kind of getting a sense of, how prevalent, what are the problems and how prevalent are they, and trying to document how many there are. I think there's also a component that if you can do destructive testing, a lot of these buildings, like we didn't build this building, it was built well before us, so you don't really know what's behind the facade until you take it apart a little bit and investigate. So that's how we found the friable asbestos tar paper behind the CMU block. That's how we found some components that were in the original drawings, like some additional insulation that turned out not to be there. So I guess the original developer maybe cut some corners. So, there's a lot of stuff you don't know until you start taking apart the building. I think the more destructive testing, the more investigation, the more time you can spend. Obviously, it takes time, it takes resources to do that, but it just seems to always be worth it because the more you know, the more better you can plan. You're not surprised in the middle of construction when all of a sudden something you were expecting turns out not to be the case.
Great. I'm also seeing another question about financing that says, I appreciate the whole building approach, but many times only portions of the overall scope can be funded. How can both the whole building approach be balanced with the segmented project funding?
I'll talk
Yeah.
generally and then you can go specific. So, affordable multifamily housing has a benefit of they're usually receiving a chunk of money in very time segments. So there is that ability to kind of leverage that occurrence of when you're already in there. So knowing that that is not the financial model for every type of building, there is a process called zero over time, and it's again getting to know how your building functions and what is needed into your building to get to a performance goal that is set um, by the owner or by a regulatory agency, and understanding what are the initial steps that can be done or should be done like immediately, and then being prepared for when the system is facing a failure to be able to interject, like, so what you do in the middle of the night, like you don't have to make those split decisions, and in the process you've reduced your energy load with some foundational energy efficiency measures, so that switch isn't so great. But yeah,
Yeah, I mean, kind of similar here. Like I said, there's additional energy, especially with the HVAC systems electrifying. We're now looking at current projects we're looking at rehabs for, but for this one it's just a little bit too much, and we put in the high performance existing in-kind replacement, but didn't do a wholesale transformation from gas-fired to electric for this one, but that'll be a future endeavor. We also, for the overcladding in particular, we did briefly look at, the windows we put in 97, so they're old, they weren't that old. Was there a way to overclad, keep the existing windows, and then come back in 5 to 10 years and integrate new windows with the existing system? And yes, it was theoretically possible, but it would just been much, much more expensive. And you wouldn't have as good of a installation performance because you'd have to kind of go back and reintegrate these two systems at different times. So for us, it was just worthwhile to take the time and wait to put the resources together to do it all at once and just have a unified system. I think people can everyone's situation is different, and maybe you have a availability of short-term funding and it's worth doing kind of a two-step approach like that with an overcladding system. It's just we decided it wasn't worth it for the overall cost, and also just the way affordable housing works, you kind of get one bite of the apple. So it wouldn't have been realistic to say we'll come back in 5 years and ask for another chunk of funding. We're in this syndicated LIHTC structure. It's going to go for the next 15 years. So I don't think there was like a realistic way to have an injection in 5 to 10 years to replace the windows then. So it was kind of an all or nothing on the overcladding. But yes, the zero overtime approach on kind of other systems with electrification and everything.
Great. Thank you guys so much. And I think we're at time, so I think we're going to close out the Q&A. But with that, I'd like to thank our panelists for taking the time to talk with us today. Feel free to contact our presenters directly with additional questions, or if we couldn't get to your questions during the Q&A period as well. I encourage you to follow the Better Buildings Initiative on LinkedIn and X for all the latest news. You can find our handles by their respective icons on the left hand of the slide. And you'll receive an email notice when today's recording, slides, and transcript are available on the Better Buildings Solutions Center. And thank you, everybody. I think that's it for today.